X cubed minus 3x squared plus x minus 3 is that denominator. The first thing you have to do is factor that denominator. Oh my. Yes, if you see 4 terms, try factoring by grouping first. What can you pull out of the first group? And you're left with? What can you pull out of the second group? 1. And you're left with? Go ahead. So now, of that portion there, what's the GCF? X minus 3. If you pull out the x minus 3 from both these terms, what are you left with? X squared plus 1. So factoring by grouping. All right. Notice this is a combination of case 1 because we have non-repeating linear factors. And case 3, non-repeating quadratic factor. The sum of the multiplicities tells you the number of fractions we need. How many fractions do we need? Sum of the multiplicities, not degree. Please know the difference between multiplicity and degree. Yes, degree is the square of the second term is the 2 on the second term is the degree. All right, so one fraction will have a denominator of x minus 3. The other fraction will have a denominator of x squared plus 1. X squared plus 1 does factor, but it uses imaginaries. It's x plus I, x minus I. We're not going to do that. What is the degree of the factor in the denominator of the first fraction? 1. So what's the degree of the numerator? 0. So that's just the number. What's the degree of the factor in the second fraction's denominator? 2. So what's the degree of the numerator in the numerator? 1, which means it's linear. Bx plus c. It's 1 degree less. That did just happen. So we have a combination of case 1 and case 3. Case 1 because we have a linear non-repeating, and we have a quadratic non-repeating, and that's the case 3 part. So again, you have 4 cases: linear non-repeating, linear repeating, quadratic non-repeating, and the 4th case we're not going to do is quadratic repeating because it's way too much fun. You'll see how much fun this one is when we're all done. So factor it. If it's not already factored, this one was not. Set it up. And remember, the degree of the numerator is 1 less than the degree of the factor in the denominator, not multiplicity. So what we do is we multiply everything by the LCD, which happens to be this first fraction's denominator. X minus 3, x squared plus 1. So in the first fraction, everything cancels as we need it to be. We just get the numerator. Second fractions, the x minus 3's cancel. We are left with a times x squared plus 1 plus. The third fractions, the x squared plus 1's cancel. Now, be careful. What are we left with? And say it properly. The quantity of bx plus c, because we have more than one term, times x minus 3. I said properly. I wanted a British accent. Why didn't you guys do that? Practice that over the weekend. Thank you. All right. There's no way, well, not easily at least, of doing the whole plug-in number technique. Because in order for this to equal 0, we'd have to use imaginary numbers. Way too much fun. So we're not going to do that. Instead, we're going to use the system route. So to do that, we need to distribute. Left-hand side will stay like it is. Distributing that a through, what do we get? Ax squared plus a. Plus, and now notice we have a binomial times a binomial, so we'll have to FOIL. What does first give us? Bx squared, yeah. Outer? Minus 3bx. Inner? Plus cx. And last? Minus 3c. Hooray! And now we build our system. You compare the coefficients on the left to the coefficients on the right for like terms. So this is a 2 coefficient for x squared. Here's a coefficient for x squared and another one. So carefully, what equation can you build? A plus b equals 2. So the sum of the coefficients for x squared must equal 2. And notice we have one x on the left. Here's an x term. Here's another x term. So what equation will that be? Negative 3b plus c equals 1, yes. So that equation came from the coefficients of the x's. And now constants, the terms that don't have variables. Negative 3 on the left. We have an a and a minus 3c on the right. So what equation would that be? Good. So if you want to do this by hand, if you want to use elimination, your substitution, your Gauss-Jordan, your inverse from a matrix, your Cramer's rule, go right ahead. Or again, you can throw that into your calculator. Do your RREF command. If you did go ahead and solve this, you would get a to be 9/5. Yay, fractions. You'd get b to be 1/5. And you get c to be 8/5. So your final answer would be 9/5 over x minus 3 plus 1/5 x plus 8/5 over x squared plus 1. I know that looks crazy nuts with fractions in your fraction.